All right, the next task at hand is to figure what to do with the table value that we have once we found it. So, let's suppose that we have a z-score of, let's say negative 2.53. So we've done some work already. We joined this problem already in progress, and we have found z is equal to negative 2.53. Now, we should know from our previous work how to find the table value that corresponds to that. And what we're going to talk about now is what is the next step in this procedure. So, what we're going to do is we're going to draw a normal curve. Now, in the past, students draw normal curves of varying degrees of quality. What matters is not how perfectly drawn your normal curve is, but is it useful for your particular purposes? In the past, I've had students draw normal curves that are essentially a large triangle. So this is their picture. We have two number lines below this. Remember, this is the data scale, this is the z-scale, and it's centered at mu. The z-scale is always centered at 0. Some students simply draw a little triangle. That is sufficient if that gets you through your problem. Some students draw sort of a little semicircle like this. If that helps you, that's good enough. If some students draw sort of a loop like this, the quality of the picture is not what's important. What matters is, can you use it to find the information you're looking for? All right? So, let's suppose that our z-score is, again, negative 2.53. We draw our normal curve. Two number lines below. The lower number line is the x, or the data scale. The upper number line is the z, the standard scale. Z is the scale upon which we're going to put this negative 2.53. Remember, we have joined this problem already in progress. We know this is centered at mu, which is something that we don't have in our problem yet. And we know the z is always centered at 0. Now, if this is 0 and this is negative 2.53, then we know where that falls. We know that negative 2 must be somewhere over here to the left of 0. All we need is to the left of 0. It doesn't matter exactly how far out you put this. The scale is not important, just the linear relationship between negative 2 and 0. Don't put it very, very close. Don't put it very far away. Just a moderate amount. Let's suppose that is negative 2.53. Whenever you draw this, you will draw a line immediately above it, and you'll see why here in a moment. Always, 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 the arrow goes to the left. The arrow goes to the left. The table we are using is called a left-handed table, or a left cumulative table. And so, since our table is left-handed, this arrow always goes to the left. It always, always, always goes to the left. It doesn't matter what else is happening in the problem. It doesn't matter what you're looking for. It doesn't matter what's given. When you're using the table that we're working with for our course, this arrow always goes to the left. This arrow goes to the left. It always goes to the left. So, now we go to the normal table. And our number was negative 2.53. Negative 2.53. Negative 2.5. I can zoom in here a little bit. Negative 2.5. The digit immediately in front and following the decimal is in the leftmost column, negative 2.5. And then across the top, we find the second decimal, which in this case is 3. So, negative 2.5 is in this row. And the 3 is in this column. And so where those match, negative 2.53 is 0.0057. 0.0057. The question is, where does 0.0057 go in our picture? Table value is 0.0057. That value, that number that we find in the body of the table, the number you find in the body of the table always goes on this arrow, 0.0057. 0.0057. The number from the body of the table always goes on the arrow. The arrow always goes left. Now, what does that number represent for our problem? This is it. The 0.0057 gives us the area in the region to the left of negative 2.53. 0.0057 is the area, and remember what we said from our previous work, area is probability. So 0.0057 is the probability of obtaining a value in this region. 0.0057 is that area, which is that probability. So the probability of being in this region, the probability of being less than negative 2.53, the probability of being in this piece of the number line is 0.0057. The number from the body of the table always goes on the arrow. That always tells this probability area. If this area is what we're looking for in the larger problem, then we're finished. If this area is not what we're looking for, then we have more work to do. But the number from the body of the table is always the value that goes on the arrow. That is the probability in this particular area. So let's practice that one more time. Suppose our z-score is 3.12. So we draw a normal table, a normal curve. Every time you do these, you should draw a separate picture for each problem. Mu, we don't know yet because we're joining this problem already in progress. But this is the data scale, this is the z-scale. We know this is centered at 0. If this is 0, then we know 3.12 must go over here to the right somewhere. 3.12 is positive. And so, draw the line that continues exactly above it, and the arrow always goes to the left. The arrow always goes to the left. The arrow always goes to the left, to the left. The arrow always goes to the left. And so, now we have 3.12 in our table. It's down here near the bottom. I'll zoom in a little bit. So we have 3.1, and we're in the O2 column. Notice I'm entering from the bottom. It's a little easier. 3.12, the number we want is 0.9991. 0.9991. So our table value .9991. That number always goes on the arrow. That number always goes on the arrow. The number from the body of the table, not the z-score, the number from the central body of the table goes on the arrow, 0.9991. Now, that corresponds to this area. Notice how this area is almost the entire area. We recall the total area under the curve is 1. This is almost all of it. This is 0.9991. And that's the same thing as the probability of being somewhere in this region is given by that area, which is 0.9991. Every time you find a value in the body of the table, you're finding a probability to the left of the number in question. The probability always goes to the left. If that's what you're looking for, then you're finished. If you're looking for something else in your problem, you have more work to do. But this table is a left-handed table. It always finds the area to the left. That's why this arrow goes to the left. When you find the number in the body of the table, it goes on the arrow.